start for the session. Now in the session, first of all, I will show you about the plans. So this is the one plan for the ground floor. This is for the first floor and the third floor are similar. Okay, and then for the second floor, if you see this area, the small area, it is gone. And now for the typical floor, the rest of the area is gone, and only the this cantilever portion will come. Okay, now in this area internally, I will take the some different size of the column, and the periphery I will take the different size of column. Only in the one level I will change, not for the other all above levels. Now if you see, this is the elevation view. The below is 6 meter. The two-sided periphery is the rectangular returning walls are there. Then 5 meter, and then up to the 6 floors is 3.8 meter. Then 4.2, 4.2, and even we can model the water tank level also. Now come to the about the sizing and this part. We are taking the concrete grade M30 for beam, brace, and the for the column we take the M40, and the shear bar also we take the M40, and the rebar, so we can take FE 500. And similarly, column the sizes we can consider, which is 600 by 600, 700 by 700, 800 by 800. Walls we can consider the 200 thick wall, that is for the brick wall, and then 250 mm thick retaining wall, and the 450 by 600 beams, 300 by 600, 250 by 450, or 250 by 250. So that is the bracing we can consider. The dead load, we are considering the self-height will be the considered by the program, and typical floor load in this way we are considering. So in this way we can start our modeling. First of all, I will import from the DXF file. So before started, I will just explain you again about the MIDAS gen. Now in the MIDAS gen, you can design the any type of the structure. It is not that only you can design RCC building. No, you can design the steel building also. Even you can design the composite sections also. So it's a versatile project software. You can do the any type of the things. Even you can model the circular thing, even any type of the structures. So you can model by using the MIDAS gen. First of all, whenever you open the MIDAS gen, first you have to check the unit. I will just change the unit, kilonewton meter. Always work on the kilonewton meter. So it's depending upon you. Some people are using the ton meter, they can use the ton meter. So if you want, anytime they can change the unit. It is not the fixed unit, you can change anytime. Similarly, this is the GUI. So the tree menu and the message windows are important, because in the tree menu we are checking whether the which type of the command we are activating, or we can say which type of the load, or which type of the sections and these things we are applied into the model. So entire thing you can see in the tree menu, in the works plan. So you have to click on the works. Now in the here, right now we have just opened the model, so you cannot see anything. So it is the blank here. So once you added things, it is coming in the one by one step. Second thing is message window. Message window is very important, because whenever you are checking anything or you are doing something, and if something is not applied in the model, you can see in the message window. So it's help you or it's guide you if you are doing something right or wrong. Now next is about the structure. These are the menu. Every entire the menus are set into the horizontal manner. So I am not go more detail about this GUI and entire thing. I will directly start the model, and whenever we are doing the modeling part, I will explain you the commands also. Okay. First of all, I wanted to import one DXF file. So you have to see whether the DXF file are made in the meter or the mm. So my DXF file I am made in the mm. So I have to change first unit to the mm, then I will import. So I just say unit is my mm, file, say import AutoCAD DXF file. In the AutoCAD DXF file, it will ask me whether I wanted to, from the which file or which file I wanted to choose. So I will just say browse, and I will just select the DXF file. I will select first floor, say first floor, and just say open. Now in the first floor, now I am just exported only, or else I will say I'm giving only the center layer. If you give the various layers according to the your section type, you can import it by your things. It's up to the you can import according to the layer wise, and you can give the section or the what we can say the section properties or the sizes according to the layer wise. So this option is also available. So it's the defined by the user itself. I will just say center. Now first second thing is material property. So now with the material property I want, still I have not defined, so I can go to this triple dot option, this dot dot option. It is directly gone to the material property definition. Now you can see here, I will just say add, and now add type of design is concrete, my standard is IS, and my database I will say M30 grade. According to the M30 you can see all the data will become. Okay, if you want to modify this data, then change the standard code to the none. Now you can modify this data. It's up to user, so they can modify the data. Then again IS, and I will say M40 and say okay. Only two grade we are using, M30 and M40. It will become here. Okay, and one more thing, if you have any doubt, you can type in chat box, so that simultaneously I will give the reply. Now I come to the section, I will say add. Now most important is in the section is, if you say beam or if you say column, there is a no definition at the time of the defining the section. So it's a only the sizes, you have to only define the sizes. So now I will just say here solid rectangle and give the column size C, say 900 by 900, user, it's a 900 by 900. Apply. If I say apply, still the command is continue. So I have to only just go and change the data. Say C 800 by 800. It's 800. 800. Apply. 700 by 700. 700. 700. Apply. And then 600. Similarly, it's depend upon the sizes. You can define the any sizes. So these are the column sizes I'm using. Now I'm going for the BR. BR means that is the bracing I'm using, 250 by 250. The same I can define it here. Okay. Now I will go to the my this one. Say my beam is 450 by 600 and 300 by 600 and 250 by 450. So I will take here 450 by 600. My H is 600 and B is 450. Apply. Second is 250 by 450 that I will use at the plinth beam. I will say here 450 and 250, and one more property is there, that is 300 by 600. And 300. Say okay. If you say okay, then it will close the box. Similarly, the thickness, that is for the shear one, I will say add, and I will give the 300 thickness. Just check into our database. So 250, sorry, we have to take the 250 mm. Now here you can see in the wall we have in plane and out of the plane, means in the both the direction we required the which thickness, we have to only define the thickness. If you want the different thickness, you have to use the second option. In plane, what is this thickness you want, and out of the plane, which thickness you want. You have to click on these two options. This option or this thickness option you can use for the slab as well as for the wall also. Only at the time of defining the element you have to define whether it is the plate element or whether it is the wall element. You can see here, now you can see here everything is come, and even after that you have to check the dimension. So I just change the unit to the meter. And come to, so okay, so now I will just select the one by one. First, go to the top view. For the go to the top view, we have these icons: top view, bottom view, and entire thing. I just click on the top view, and I just click this box, this one, and this one. So these four I'm selecting. Then right click elements, and I have to say extrude. Okay, now in the extrude option we have this option node to line element. Node to line element means what happen, from the node it will generate the line, and after that you have to say my grade is M40 900 by 900 and my height is minus 6 meter. If you see in the our elevation view, it's a 6 meter. And just say apply, or if you see in the 3D, I will say apply. Now you can see this for 900 by 900 column is generated. Now one more question is coming here. If you are defining the shear wall and the slab as the same, then there is a no change in the resultant force. No, actually this is only the section sizes we are defining. At the time of defining the element, there we have to define whether it is the plate element or whether it is the wall element. So I will show you at the time of generation of the shear wall, because the section means it is in the MIDAS means what happen, it is only the sizes. There is a nothing link between the anywhere, it is only the sizes. But whenever you model the element, it will consider whether which type of the element you model. So this is the most important. Okay, especially at the additional shear and the movement in the shear wall. Yeah, I will explain you once you model the shear wall. I will explain you what are the things we have to consider at the time of modeling the shear wall. Only we are defining right now it's a thickness. Now next is I just select this one columns 1, 2, 3, 4, 5, 6. Okay, this 6, and just say 700 by 700. Same, apply. Now I will select these 4 corners. This is 700 by 700, and these 3 corners, this is only the 600 by 600. Okay, because of the irregularity of the building which the model you are showing. Irregularity of the building which the model you are showing. So generally in this model, this is the small irregular actually structure. If you see the various level, and this is is only for the your understanding purpose, means how you can take the how you can import from the DXF file, and the similarly how you can take from the how we can see the results and the modeling part. It is not based on the means actual project and these things. I'm just taking the some how we can take it from the AutoCAD DXF file. Now I will select the this one and this two, and here I will give the size is 900 by 900. Just say apply, and now lastly I just select these two and just give the size 700 by 700. Say apply. Now you can see all the columns and entire thing is selected. Now second thing is I wanted to generate the shear wall. So now in the shear wall, 1 2 3 4 5 6. So in this area I wanted to generate the shear wall. Okay, only this much area. So same thing, I just select the line diagram, right click, element, and I will just say extrude. Now in the extrude, previously we said no to line element, means for the generation of the column. Now I wanted to generate the plate element, so I will just say line to planar element. Now in the planar element it will ask the element type, so I will just say it's a wall element. So here we have a difference, the plate element or the wall element. If you consider the wall element, it will take according to the shear wall. If you take the plate element, it will take according to the slab. So we have these two options. We have to consider the wall element, and if you take the wall element, no need to mesh the shear wall. Say just say element type is wall, my grade is M40, my thickness is 250. Now again it will ask the membrane or the plate. If you say the membrane type, so means shear wall as a membrane, means it will only take the in plane movement. If you want to consider the out of the plane movement also, so you have to say plate element, because in the plate element it will take the both the movement in plane and out of the plane. Be careful whenever doing the shear wall. Whenever you are modeling the shear wall, you have to click on this option that my type is wall and my subtype is plate element. It's a -6 meter, and then I have to say apply. Now it will generate. Now one more option is come, that is the wall ID. Here you can see the wall ID. Wall ID means it is the numbering of each and every wall. Now I just say closed it. Now in the element type here you can see wall. I just double click here and I will say activate. Activate means what? Only I wanted to see the shear walls. Otherwise, come to the top view. Now here you can see the shear walls. If you want to give the different wall IDs, just click on the display option. Just go to the view, say display. Now in the display option we have in the element that is the wall ID. Yes, for the retaining wall and the shear wall, both the element you have to choose, because sometimes some persons the retaining wall they are model as a plate element, so they can consider the plate element, because if you model the plate element it will take the horizontal or the soil pressure also. If you model the shear wall, means a vertical element as a wall type, then it will only consider the vertical forces and the lateral seismic forces, not the soil pressure. So it's the depending upon the design engineer which type of the element they wanted to model. Now I will just change to the numbering. Now you can see everywhere it is the considering the one numbering. I don't want the one numbering for each and every wall. If you want, you can change it. So I just come to this option, nodes and element, and you have to say change parameter. Now what is the meaning of change parameter is, once you model the entire thing, then you can change it anytime. Okay, Mr. Abdul is asking the one more question regarding the import DXF file. When we import the DXF file, nodes does not form at all intersection, as it is not important to have a proper nodes to transfer the loads. No, it is important in the MIDAS gen. Whenever you import from the anything from the AutoCAD DXF file, so the program itself automatically break at every junction. If it is not divided element at the joint, then it will not transfer the loading. So it is the most important in the MIDAS gen. Each and every joint we require to break the element. For the break element, we have this option intersect. Just select all the element and just click on the intersect option. Program automatically break each and every intersect, so that your load transfer will be proper. Otherwise it's give the error. Now next thing is come to the wall id. Now for the wall id, if you see the wall id, say wall id it's a 1. I will say 1 2 3, apply. If you say auto increment, the automatically the program take the second number. Again I have to just select 1 2 3, column to column I am selecting as a 1 grade, 1 PR level, or you can say wall id numbering. Wall id numbering is very important. You cannot give the same wall id in one floor. From the bottom to top you can give the one id, but from the in one level you cannot give the same wall id for the different wall. Otherwise it will combine all the stresses and give the result. So that is the wrong concept. So generally we use the same wall id at the shear wall, sorry, at the lift wall or something. Otherwise each and every rectangular wall you have to consider the different wall id. According to that wall id it will calculate the area and CG and give the moment of inertia, and it gives the results. So it is the most important to choose the wall id properly. Now my one level is completed. Second is I'm again importing the next level. So I will just go to the file. So before going to the next level, I will just come to here and just change my unit to the mm. File, import AutoCAD DXF file. Same. Now this time I will say it's my second floor. Okay, say center M30. My section I will say 450 by 600. Level I'm considering 000 level, because in the AutoCAD itself you can give the origin according to the Z level, or else you can change the, you can consider at the one level and you can define the Z level also. So right now I'm giving the origin in the AutoCAD file for the second floor. So I just say apply. Now you can see I just show the elevation view. Now you can see this is all coming into the that level. Okay, according to the my AutoCAD file. Now I wanted to generate the columns. So what I will do is just say elevation view and go to the walls. I just select these walls and just hide this option. Means I don't want to see the shear wall at the bottom level. So I just go to the view and in the activate, inactivate and all. So activate means I wanted to see. So inactivate means the particular selection is gone. So I just say inactivate. Particular selection is gone. Now I will just select the bottom level plans, the bottom columns. Now you can see I'm selecting all the columns. If you want you can rotate it. See here all the column is selected because the same column is going into the next level. And if you see the next level height, it is the 5 meter. Okay, so now for the 5 meter just go to the structure, say control data and say building generation. Here you have to say 5 meter add, and we have the various option. Copy the node attribute, means if you see if any supports are there, if any nodal loads are there, so the entire thing is copy into the another level. So it's depending upon the users how they wanted to copy the elements into the next level. Then I will just say apply and just say view and say all, activate all. Now you can see the entire thing. So everything you can see in this level. Now in this level this half the part is not there. Okay, so in this way you can see sometime in the some of the persons might be they are facing one problem in the shear wall. They cannot see the thickness if they on the extrude view also, so they have to use this option. Go to the display option, and in the draw we have this option, hidden option. In the hidden option they have to click on these two options, the frame thickness and the plane thickness. So if they click on these two options, they can see the shear wall thickness also, or the plate wall thickness. Second thing is, if they wanted to see the element by different color, again I have to go to the display option, not a display option, and then go to the draw, and in the draw we have this option, global color. If I say global color apply, so it shows the same color. If I say element type color, now you can see this is the one type, that beam, and this is the shear wall is different color, so plate is different color. So it is the according to the type wise. If you say the material, it will show according to the material wise. Now you can see here it is showing the same color, then you have to click on the random color and then click on the apply. So program automatically take the random color. And then last one is the section thickness color. Again we have the section thickness color, just click on the random color and just say apply. The program automatically take the different color. No need to go and manually define it. If you want, you can define it in the color box. We have this option. Otherwise you can use the random color option. Okay, now next is I wanted to generate at the next level. So again I go to the my this file. I will say this is my again 5 meter, next level is 5 meter. I will just change to the my unit file, import AutoCAD DXF file, say browse. Now my first floor and third floor are same, so I consider the first floor my center, but this time my section sizes is 450 by 600. The rest of the thing is okay. But now in the origin point, in my that AutoCAD file, I consider my origin it's a 00 level. I wanted at the particular 10 meter level, so now I can change it here 10 meter, and I just say apply. Oh sorry, 10 meter, so 10,000, because my unit is in mm. 10,000 I just say apply. Now you can see it is coming here. Okay, otherwise you can go here and you can, if you know the particular point, then you can go and click also. So automatically program will take the dimension and only give the origin 00, that 0 comma 0 comma and 10,000. It will automatically take here. Again I will take this column, structure, control data, building generation, and the 5,000, because it's in mm. You can see the unit mm. Why I am using this option is because say the my below is 6 meter height. In the next level I want the 5 meter, means I wanted to reduce by the 1 meter. So you can use this option, building generation. Now if my column is 5 meter and the next level is also going the 5 meter, I can copy that particular element also. Just select this element, just go to the element and just you have to say translate. Again in the translate we have option copy. You can copy into the particular any one level, but it is the based on the actual height it will copy. If you wanted to varies in the height, then you have to use the building generation option. Now my this one is done. Now my next level is build control data, sorry, file, import AutoCAD DXF file, say browse, and I will say 4th floor, center, it's a 450 by 600. That one is okay, and just say apply. Now this time I will already manage the entire thing. Now in this way I just again select the all the columns, say control data, building generation. Now my height, I have to check the my height. It is considering the 3.8 meter, 3800. Say add and apply, say close. Now you can see here 3 column. I don't want these 3 columns, so I can select in this way. I just select this one in the elevation and just say activate. Now you can see in this way, I just select this one. Whenever you are selecting anything and if you wanted to delete anything, don't directly select and delete it. Otherwise that node and entire thing will be deleted and it will create the problem, because whichever the joints are there, along with that joint, entire thing will be deleted. So just select this one, go to the nodes and element and go to the element. You can see element and just say delete. Selection with the free nodes, apply. So program will delete the free node also and the element also. It will not directly delete the node. If you delete this bottom node, that below connected column and the connected joint, every whatever the connections are there, entire thing will be deleted. So be careful whenever you wanted to delete the anything. Now my next thing is, I just select this one. Now I wanted to change the size of the particular beam. Now you can see this much area. I just select this much area, I just zoom it. We have this option window zoom. Okay, now I just wanted to change the size. How I will do, just select the element and go to the tree menu, and now you can see here I just want 300 by 600. Just click and drag it to the screen. Now you can see the size will change. Okay, how we did, just select the element and from the tree menu you have to click 300 by 600 and drag it to the screen. Now you can see entire thing. I just say active all. Okay, go to the view, this one say active all. Now you can see the entire thing, it will shows the entire model. Okay, now the same this level I wanted to copy it. I will just select this one level, one floor. My height is 3.8 up to the 5 meter, then 4.2, 4.2 and 3.6. Okay, so what I will do, again I go to the structure, control data, say building generation, say 3.8 5 times, because already we did one time. Then one level, that is 4200, sorry, that is the 2 times. If you see here 4.2, 4.2 and then 3.6 meter, 4.2 2 times. Now I will just say apply. Now my whole structure is generated. Now I wanted to generate the my water tank level. I just select my top view and I just select the entire portion, okay, in the internal middle portion, and I will just say one level, that is the 3.6 meter, 3600, say add and apply. Now I will just say activate all. Now you can see my entire thing is generated. Now one more thing is remaining, that is about the bracing. Still we have not defined or we not model the bracing. So how we can model it? So I just come to the top view and I just select the first these two lines and these two lines. Okay, and I just say activate. See, I'm working on the top view, okay, and everything is activated. And if I say only those portion whichever I selected activate, now in the view you can see whole structure is activated. So in whatever you are doing, you have to be careful where whenever you are selecting the elements. Now I just come to this option, go to the nodes and element and you have to say create element. In the create element we have this option element type and you have to say truss element. Now in the truss element means what happens. So sorry, first of all I will explain you about the element type. Now in the element type you can see the truss means it's only consider the axial forces. The tension only options are available, compression only, general beam and tapered beam we use for the normal beam and column, and then plate element, plane stress, plane strain, axis symmetrical, solid element, and the wall element. So various types options are available, and according to the type they will give the results and the behavior. So be careful whenever using the any type of the elements. Okay, sometime in the most of the program what we did, we model as a beam element, then we released it so that it will consider only the axial forces, and according to that we did. But in the MIDAS gen we have the direct option. You can directly use those option for the generation of the elements. So I will just say truss element M30, say BR, and click on the nodal connectivity option, and I just click first box and incline. If you generate it into the one floor and then you copy, then also it is fine. Otherwise you can done it in the later on also, because I just wanted to show you how we can model the this type of the element. That's why I did these things. I just model the entire elements, and after that our modeling is part is over. We started for the loading part, and before that we have to do the 2 or 3 settings. In the horizontal level, that horizontal level, actually at the time of importing I break this particular these things. If the nodes are not there, the program will automatically take care according to the snap midpoint. If you see here, program automatically take the start point, midpoint, and end point. So right now I wanted to generate it at the midpoint, and according to that program automatically break the element. Whenever you model the anything, it will automatically break. And if the any nodes are not exist, then you have to generate the node and then you have to model the your element. Just say activate all. Again I go to this top view. Now I will again select the two things. One is this one area and this one area, and just say activate and see the 3D view, and just rotate it for the better view. And now zoom and again model the bracings. Yes, you can copy the nodes and this one also, but whenever you are copying, you have to be careful. If it is the height are same, then it is okay. If not, then you have to use the building generation option. Okay, so that is the most important whenever you are copy the entire thing. Now my entire modeling is over. Now I just go to the display view and I just off first wall ID. Now I wanted to tell you about the one more thing. Yeah, now you can see everything is set according to the center to center, but we generally use all my beam to be a flush from the top of the column. If you see in my column, it should be the come down, means that beam should be the come down, not the column height. That beam should be come down, so that it will take the proper results. So how we can do is just go to the structure. Just go to the structure and just say structure type. Now in the structure type, first of all you have to click on the convert the sulfide into the masses. This is the most important option, because in this option uh, we are click on the convert the sulfide into the masses, so that what happen, the sulfide is automatically considered for the masses for the calculation of the seismic load. So if you want to consider only the seismic in the x and the y direction, then you have to click on the convert xy. If you wanted to consider the three direction, then you can click on the xyz. So it's up to the design engineer. Then these two options are most important, that is the align the top of the beam section with a floor for a panel zone effect. For a panel zone effect means what happen, if you do these things, and the program at the calculation of the movement from the face of the column, for the beam it will calculate the movement, and for the column from the bottom of the beam or the beam base it will calculate the movement. So it will neglect the overlapping areas. So I have to click on these two options, just say okay, and then if you see here, the program automatically take care of the top and this one areas. Now one more question is come about the why you are giving and consider the truss member. Actually I just wanted to show them how we can model the truss element also. So that's why I'm considering the inclined portion, and that particular inclined portion I am not modeling the shear wall, so it will help for the lateral resisting as a lateral resisting element, so they can use in this way. Now next is control data. So in the control data you have to come and you have to say story. In the story just say auto generate story data. Auto generate story data means what happen, right now we are modeling we are only the modeling our structure, but we wanted to give the story data also. How we can give the story data? So these are the portion we can see. The first my level is -6 meter, then second floor is my at zero level, means this is my zero level, then 5 meter, then next is my 3.8, 3.8, 3.8. According to that you can see the my dimensions are there. So if in between any points are coming and that particular point you do not want to consider as a floor, then you have to send it to the unlist option. Otherwise it will consider the diaphragm at that particular level. Whatever the things we are defining here, it is only the consideration of the diaphragm. And the one more thing is include the seismic accidental eccentricity, that is the 5% of the plant dimension, and the second is the wind eccentricity, that is the 15% of the plant dimension, that is you are considering in the at the time of the generation of the floor data. So these two options are available. If you want you can edit it any means at the time of the defining the floor data. I just say okay. Now my all the data will come, and now you can see here consider means what happen, it is my rigid diaphragm. If you click and if you say do not consider, so it is my flexible diaphragm. So whenever you model the flat slab or any slab, so it is the semi rigid option. Okay, so the user has to define the which type of the diaphragm they wanted to consider. Then I will just say close. Now you can see here my floor is generated, my how much the nodes, element, and the material and entire thing. Now I wanted to give the second part is the check options. So we have this option check duplicate element. Whenever you click on the check duplicate element, so you have to check this option, say check duplicate element, zero element have been deleted, means there is a no duplicate element. Because sometimes what happen, whenever you import from the AutoCAD DXF file, sometimes it is the some duplicate elements are there, so program automatically delete the duplicate element. no need to, and so it will give the error whenever you give the what you can say, at the time of the loading it will give the error. So we have this option. Now one more the question it's come, if any level difference, rising floor or sunken slab, whether it consider in a same level or different level. Generally the rising floor and the rising the sunken slab, we are generally not modeling into the structure. If you wanted to model it, we have one more option in the properties, thickness, modify. You can see this plate offset. You can define the plate offset also in the z direction in the which level. So the eccentricity it will consider by the program, but it will show at the one level, but that particular eccentricity will consider by the program. So these options are available, and it shows into the one level, but it is into the another level, especially for rising floor of 600 plus level. So you can model the slab according to that. And otherwise if you want you can model the actually also, but if you model the actually then it will what we can say, so at the time of defining the floor level you have to be careful. I mean that particular that 6 mm 600 mm level you do not have to consider into the floor. Okay, means at the time of defining the diaphragm only you can model it according to that, whatever the means connecting member, it will transfer the load and the movements, but it will not consider the any diaphragm. Yeah, you can model if you want, you can model it here itself. Otherwise if you want you can use the this thickness offset option, the plate thickness option, plate offset. So it's up to you. If you want you can use the both the option. These two options are available. I'm telling about the diaphragm because if you model actually model the 600 mm above, then it will program ask for the diaphragm. Otherwise if you only give the offset, then it will not ask for the at the time of the generation of the diaphragm. So if you model, then no need to consider the diaphragm, that I'm saying. So you have to be careful whenever generating the diaphragm. Otherwise you can model it, it's up to you. Now I come to the next part, is about the boundary. Now in the boundary, right now we are modeling as the normal structure without raft. So without raft we check the design and entire thing, and the later on I will explain you about how we can define the raft and entire thing. So first just go to this option, select by plan. Now in the what is the use of this select by plan, I will just explain you. First is XY plan. If I click on the XY and if I click any point, program will select only the XY plan. If I say activate, you can see only the particular level. Similarly, one more option I have, that is the XZ. And if I click on this particular one point, what the program will do, program will select one particular level. I just show you it to the middle level. Okay, I just select this one level. The program what will do, program will select the X plane and the vertically, and if I say activate, now you can see the elevation. So within a one click you can generate your own elevation view. No need to go and generate the grid and these things. So the program automatically generate the elevation view in a one click. We have this option select by plane. By using the select by plane you can activate the this level. Similarly, if I see YZ and the same point I am selecting, the program will select the Y plane and the Z, and if I say activate, program will show you the elevation view. So it's up to the design engineer, wherever they wanted they can generate the elevation view. Now I will just select again, select by plan XY and select the bottom nodes. Now you can see all the bottom nodes are selected, and I'm going boundary, just say define support. And now in the boundary I will select the DOL and ROL. DOL means that is for the translation, ROL that is for the rotation. And I will just say apply. Now all the structure support are selected. Now one more option I wanted to tell you, whenever you generate the floor, means in the structure control data story, now one more option is activated, that is in the view all, that is the active by identifying. Okay, view activate all. That is the active by identifying. Active identifying means what happen. Now I will just open my floor level. Now you can see a floor level, my second floor, any floors. If I wanted to see the floors, how we can see? Go to the story, fourth floor, and if I say floor, activate. This will show only the floor. There is a no horizontal means vertical and if I say activate, it will show you the above columns. If I say below, activate, it will show the below column. If I say both, activate, it will show the above column. Now you will see it like if I select the second floor, say fifth floor, eighth floor, and my I will say my 12th floor. And if I say activate, now you can see alternative floors and you can do this thing. So alternative floors also you can select it easily. So this is one more good options are available. Now I will just off these levels and another one more option the boundary is done. Now another in the boundary option we have the point spring generally if you wanted to model the pile, but no the not the exact the pile but that the stiffness values. If you wanted to give the spring values, so you can give the spring value to the particular point at the what you can see at the pile levels and you can check whether it is passing or not. Second is the surface spring. Surface spring is used for the subgrade modulus values. Means whenever you model the raft, you can use the surface spring value. So with the help of the surface spring, you can define the point spring or else the area spring. Means it is the subgrade modulus value for the designing the raft. You can use this option. Now general spring and the pile spring support option is also available. Means if you wanted to put the horizontal spring support, if you wanted to give the horizontal spring support, you can use the pile spring support. So we have various options, the dense soil and this one, the sand, clay, soft clay and the stiff clay, and even the soil type also we have dense, loose, medium. So various options are available. According to that you can define the horizontal spring support. So it is not only the vertical spring support, we have the horizontal also. Yes, according to the area wise, it will consider the corner, middle, and the center spring automatically. Only we have to give the value which is the kilonewton per meter, and according to that, the area it will automatically consider. No need to go and manually give the each and every point the stiffness value, spring values. Now the next is the again the elastic general link. These options are available. Generally, this is used for the what research purpose, because in this option we have the various option like isolator. We can say the viscoelastic damper, gap, hook. Hello, hello. Yeah. So now in this way you can see the viscoelastic damper, gap, hook, hydrostatic, LRB system, pendulum system. So various options are available to model the dampers also. So you can use this option for the higher analysis option. The you are asking about for the center and the edge and the corner spring. Generally, if you give the area spring, the according to the area is program automatically calculate the spring and transfer it into the corners. Means each and every nodes. So no need to go and manually calculate the spring according to the edge, corner, and this one. So program it will automatically calculate the subgrade modulus value or spring values at each and every nodes. Only you have to give the kilonewton per meter values, meter square values, it will automatically consider. Now the next thing is about the beam and releases, beam and offset. So these options are available. Means if my secondary beams are there, now we can see here, this is my secondary beams. I will select this one beams. Okay, now in this beam, if I selected and I wanted to release it, just go to the beam and release, and I will just go the both the end, say apply, both end are released. Now you can see the green dot. Now one more thing is I will just select this point, this one, and this one, and I will say start point. it will release at the start, and now here and I will just say at the end apply. Now what happens? So it will not transfer the moment to the main beam, only it will release at that moment. So this option is also available. You can use this option. Now next is panel zone effect. Just click on the panel zone effect so that program will automatically give the movement from the face of the member. So just click on the auto calculate panel zone effect and just say okay. So now you can see the entire thing is done. Now next is about the loading part. Now I will come to the load. First is the load. Now in the load, first is the static load. In the static load, we have to say static load case. Just click on the static load. I will just say S self weight. Okay, or else you can say SW, that is the self weight. My type is dead load, say add. Here only we are defining the which type of the load you wanted to apply and what is the my type means, whether it is dead load, live load, earthquake load, wind load. So which type of the load, the type you have to define. Type is very important because otherwise at the time of the load combination program will not identify. Otherwise means program will not give the auto load combination. So you have to go and manually give. So most important is the give the type properly. SIDL, that is the superimposed dead load. So I will consider the SIDL, that is in the what we can say the my wall load or else my floor finish load. So these are the I am considering into the SIDL. I will come to this option. Now you can see here dead load, superimposed dead load and the live load. So these options are available. Say LL, that is the live load. My type is live load, say add. Now next is wind X. My type is wind load on structure, say add. Say Y, wind load on structure, say EQX. I'm normally considering the earthquake forces. I'm not considering the eccentricity, that is the positive negative eccentricity cases, but I will show you how we can define it. Now these 7 cases are done. Just close this. Only this is the we are defining the name. Now you can see here in the tree menu it will come by name. There is a no plus sign, means we are not defining still anything in the particular load case. Now by next step, in the structure load we have this option self-head. Self-head means what happened, still the program doesn't know in the which load case you wanted to calculate the self-head. So I will say here SW case I wanted to calculate the self-head, and you have to just say Z is -1 add. Now program will calculate the self-head into the SW load case. Now you can see here it will come the self-head into this option. Now next is load to masses. Just click on the load to masses option. This is the use for the calculation of the seismic weight. Generally for the seismic weight we are considering the self-head is 100%, even SIDL is 100%, and my lateral load, what means my live load I am considering is the 50% or the 25%. So now I am considering here my self-head is 100, my SIDL is 100, and my live load is 0.25%, that is the 25%. So whatever the total loads are there, it will automatically manipulate with this factor and give the seismic weight. Now you can see here my load to masses are also done. Now there is a no consider for the earth pressure retaining wall definition. If you want you can consider, I will show you. Right now we are not put the earth pressure on the retaining wall. So if you want I will show you how we can do it. So you have to generate into the another case, that is the earth pressure, or else you can consider into the live load also. It's up to the you. And then in the loading pattern I will show you how we can define the earth pressure, or that is hydrostatic pressure. Now these two things are done. Now next is the element loading. Now in the element loading, that is the load, I will just select the section wise that is the first 250, this one and this one. I just say select and activate. Now you can see all the loads are activated. In this area, by default right now I'm not calculating the too much thing. I'm just applying the throughout the same loading. Okay, this particular the bottom level, I just go to the beam load, static load, say beam load, and I just go to the element. And in the element loading, I'm considering the SIDL, say replace, and right now I'm applying the same load, that is the 12 kilonewton per meter. Sorry, it is in the unit exchange, say meter. That is the 12 meter. And just say apply. Now you can see everywhere the load is applied. Now in this area I will just select this much part. Now this is the roof. So now in this roof area I will select only the periphery. Just selecting this one, I don't want this one. So we have one more option, that is the unselected by window. So which are the part we are selecting, that is unselected also. So this option is also available to select and unselect. We have this option, that is the unselected by window. Now all the periphery is selected, and I will say here 6, say apply. Only the periphery, this load I am considering, say activated. Now my entire things are done. Now one more thing is, if I wanted to change the loading, how we can do is, I will tell you one more thing. Now in the loading, first of all you have to select the particular element. I just off my extrude view, just go to this option, hidden, just off it, you can see the normal line view. Now come to the element. Now here put any values and just say replace, so automatically it will change the value, or else if you want you can delete it. One more option in the load type, we have uniform load. Similarly, we have the concentrated force. You can apply the point load, concentrated movement, uniform load, uniform movement, trapezoidal loads, trapezoidal movement, uniform pressure. So these are the options are available. Even we have one more option, that is the typical. Typical means you can apply the UDL, two triangular, single triangular, three triangular, trapezoidal. So this option is directly applied to the particular beam. So sometime if you want, you can directly apply this loading. No need to go and calculate each and every length and these things. So this option is also available. Now one more option is, go to this option element loading. In the loading you can see in the SRDL, you can see the element beam load. Just right click and just say table. If you say table, now entire things are coming into the table. In this particular table, yes, torsion beam also you can perform here. If you know the values, you can apply the torsion moments, and the program will design according to the torsion beam for the torsion moment. Now in the table, if you see, element numberings are there. If you see here, I just select the any one beam. Now here will select the, you can see here 888. So this is the my 888 beam number. I can change the my SRDL loading or any other type of the loading if you want. And if you go ahead, now here you can see the values. Here you can change the values. Here you can change the value, because right now I'm changing the unit. If I change the unit, you can see the 1212. So you can change the value. So these options are available. Okay, now next is, 1 minute. Yeah. Now these are the some options are available. Now in this way you can see the what are the things you want, you can do it. Okay. 1 minute. Yeah. So 1 minute. You are asking about the torsion of the beam can be performed. Yes, actually we can perform here the torsion beam and the entire thing. Actually, at the time of the element, yes, it is possible to provide the sloping slab also. So it is the modeling technique actually. You have to know about the all the nodes anywhere. So if you want, I just show you for the one element. Yeah. Now you can see this is the one inclined part. And if I go to the nodes and element, and if I say plate M30 grade, it is the 4 noded 250. Now you can see this is the my inclined member. Now you can see in this way we can generate the my inclined slab. So we have this option, you can generate the anywhere. And in the about the beam loading, in the loading element we have this option, moment and the torsion. You can apply the torsion load, and at the time of the designing, whether you wanted to design for the torsion or not, you have to select those options. In the design we have this option, say RC design, sorry, IS456, say design code. In the design code we have this option torsion design. If you click on this option, then program will calculate for the torsion, otherwise program will not go for the torsion design. So it's up to the user, they have to select this option. Now next is about the these options. What are the options? This pressure load and this one. Now in the pressure load, generally we have this option, the pressure load. Pressure load means what happen whenever you model the slab element, means if you know the entire flat slab, we can say in the flat slab, if you know the loading, you can select the manually and you can directly apply the loading. For that reason we have this option pressure load. The pressure load, it is for the FEM based analysis. So each and every slab, it is directly transfer into the particular node and nodal and node, from node to element it will transfer. Second thing is hydrostatic pressure. So this is the one option which is used for the lateral loading. So in this option you have to give only the this data. First of all, this option will not work for the shear wall. It will work only for the plate element. So you have to model the vertical plate element. It is not the shear wall. The type is plate. Okay, not subtype. Main type is plate element, not a wall type. Then you have to click on the reference height. You have to give the reference height. Constant intensity means it is the surcharge loading. So you have to define if any surcharge loads are there. And the gradient intensity means in the gradient intensity you have to only put the value that is your soil density into your active pressure value. Means what is the your active pressure, that is the 1 plus sine phi upon 1 minus sine phi into soil density. So that particular value you have to define here. The height, it will consider according to the program, means whichever the element you are selecting and whichever your reference level you are giving, based on that it will calculate the soil pressure value. So here you in the gradient intensity only you have to give the Ka into soil density. Okay, K, that is the 1 plus sine phi upon 1 minus sine phi, and the density of the soil, whichever, maybe it's 16, 18. So according to that you have to define. Now next is assign floor load type. Now we will go for the floor load type. I will just say define floor load type. In the floor load type means what happen, it is the grouping actually. So here we have to define the group, means which type of the load you wanted to apply it into the structure. So I will just, okay, one more question is coming, that is the whether the program automatically detect the consider the center edge and the corner spring separate modulus value. Yes, I said it will consider, means what happen, it is the based on the area. We apply the load into the area, and based on that area and that the particular point, it will transfer it into the particular point. So you have to define whether that particular spring, means that particular load will automatically transfer it into the node. So that particular area is depending upon that area, how you model that area, and according to that area wise it will transfer into the particular points. So these options are available. And for the punching, at the time of the punching, it will consider based on the your edge punching and this punching. So according to these options are available. So these options are available. We can do it in this way. Now next is coming to the my floor load type. So I will just click on these options. Yeah. Now my floor load, you can see typical floor load. My dead load is 2.5, SIDR is 2, and live load is 2. So my typical, my self-head is minus 2.5, my SIDL is minus 2, and my live load is minus 2, and just say add. Now one typical load is done. Whenever you are defining anything, just check the unit. In the front of that unit will be mentioned. Next is staircase 4.375, 2 and 3. Staircase 4.375, 2 and 3, and just say add. Okay, so it's depending upon the your values you can consider. And then roof floor, dead is 2.5, SIDR is 3.25. And it's 1.5, and just say add. Now my these three loads are done. I just say close. Now at the time of the loading, we have to define the loading. First, it is considered the plinth level, so no need to define it here, but we can define it at the staircase level. And if you know the exact my height, so you can define it into according to that. So I will explain you how we can do it in this way. So first is, okay, I will just select the my one floor, that is my second floor, say floor activate. Generally work on the floor only, don't work on the anywhere in this way. Now in this area I will consider my staircase. So right now it is the in the rectangular portion, so I will consider only the two-way loading. Okay, it is not the dog light staircase, so you can consider in this way. One more thing is, do not we model the slab instead of applying the slab load. Generally we have the two option. You are asking about, one more question is coming, that is the do not we model the slab instead of the applying the slab load. Generally if we apply the slab load and if we model the slab, then it will consider the plate stiffness. Okay, means here we don't have the option called the membrane analysis, that is the according to the yield line theory, and it will not transfer the load according to the one-way two-way mechanism. If you model the slab, it will transfer load according to the FEM analysis. So whenever you model the flat slab or raft, that time we only model the slab, otherwise we directly transfer the load to the connecting beam. So that's why we are not modeling the slab. So it's depend upon the situation. If you have the slab this one, then you have to model the slab. If you do not have the flat slab, then no need to model the flat slab. Now I come to the loading. I just say assign floor load, say staircase. Here I'm considering the two-way loading. Yes, if right now we are ignoring the slab stiffness, because membrane slab doesn't have the stiffness, only the flat slab, it's plate element having the stiffness, and that is the more stiffness. So for that reason we have to model that particular flat slab. It will help in the at the time of the horizontal what we can say, horizontal displacement also. That's why flat slab and the membrane analysis, the procedure was different. Now I consider the staircase two-way slab. One more thing is, if I wanted to copy into the floor load, I just click on the copy floor load, and I will just select first these nodes, 2, 3, 4, 5. Oh, sorry. So now first I wanted to copy it. So I will just say Z. Now I have to mention the distance. Now what are the my distance are? 1, 2 times 5 meter, 6 times 3.8 meter, and 2 times 4.2 meter. Here is 2 times 5 meter, 6 times 3.8 meter, 2 times 4.2 meter. At the rate means it's a multiplication, we can say. It's a 2 times. First you have to distance, you have to mention the number of times, and then you have to mention the height. If height and these values are not matching, or means that particular area, that beam is not there, then it will not transfer the loading. So be careful whenever defining these areas. Now you can see here, this is done. If for the more these things, I will just show you. Now in the tray menu, you can see this is the floor load 11 time. I will just say display. So in this way, the floor loads are displayed. Just go to otherwise you can go to this option display. Just go to the load and you have to say floor load, floor name, floor area. So according to that it will shows here. I will just say floor load, say apply. You can see here floor load name, floor load area, just say apply. Now you can see each and every floor it will add the my loads. So these options are available. Even from the tray menu, you can right click and just say display. Now you can see in this way. Otherwise, right click and just say table. And if you want, you can change the distribution also. If you want the one way, you can change it here from this table. Even you can want load table, load type, you can change the load type also. So these options are available to change the entire thing, distribution type. So if you want, you can delete it by from the table also. So these options are available. Now I will go to the next level, that is the third floor, activate. Now one by one we can define the loading. Only for this level we are defining in this way. From the next level, 2 levels after that, we can directly define the loading. So I just go to the assign floor load, say typical, say one-way loading. It's a 90-degree, okay. Copy load into the next level, that is the 5 meter, and by this one angle is right now I'm considering the 0. So it will transfer into this direction because we are giving the angle is 0 degree. If we give the angle 90 degree and then we define, so it will transfer according to these values. Even for the triangular also, it will transfer according to that. Sorry. I just select this one, and for this area my distribution will change. So I will select here 0 degree. Yeah, now this one is done. Okay, now I will go to this option. If you see the entire thing, again I'm just clicking on this option and I will select the fourth level. It is done. Fifth level, yeah, yeah. Now here I will just say it's typical level one way is a 0 degree, Z level 6 time, sorry, it's a 5 time 3.8, and then 2 times 4.2 meter. And just say 90 degree, and I will apply 90 degree. I will apply the loading from this point, this one, this one. Be careful whenever you are doing the point loading, this lab loading. Don't work on the top view. Always work on the 3D view, or else only open the XY plan, because it is based on the your nodal option. If nodes are improper, then it will create the problem. So you have to choose the proper XY level points only. So in this way my loading will be done. Now if you see at the top level, yeah, one more level is pending, that is my this one level, fourth floor, this area. I will say typical, it's 0 degree off. Yeah, this one loading is done. Now next is about the roof plan. We are come to the roof plan. Now if you want, you can, if you know the total loading of water tank and this thing, then you can consider. Right now I'm putting the same values, and that is also the two. This is the roof, say two-way, and for one way this y direction. Now if you want, you can change it from the this table also. Just go to the table, and this table, if I come to this option and just say my 12th is my roof level, my point object. Now you can see here 522, 523. I just come here, right click, and I will just say find 522. Now you can see 522, 523, these options are available here. You can say typical, instead of that I will just say roof. It will change. So in this particular area it will change. Say 524. So this option is also available. You can change from the roof table. What are the things you want, you can change. Five 44, 543, 543. Okay. 545. So most of the slabs are done. Now one more question is come is, most of the slabs consider the one-way slab. What would the load transferred onto the secondary beams? See, generally, if you see, this is only for the, first of all, this model we are considering only for the study purpose, not for the entire purpose. Okay. So in this model, you can see the loading and this area. See here. So it will transfer into this one-way loading according to this beam and this beam to the main beam. Okay. So it will transfer only the point load and the main beam. So in this way also you can do, but actually I just wanted to tell you about that. So in this way you can do your model and entire thing. Okay. So it is not that we are using this is the actual project or this thing. It is only for the study purpose, but you can change into the your model, or based on that you can see. Okay, now my this one is done. Now next is about the lateral loading. Now for the lateral loading, come to the wind load, and I will say add wind X. My code is I875. Again we have both the method, standard method and the gust factor method. Again gust factor method, you have to calculate the GFX factor, that is in the gust factor in X direction and the Y direction. Then right now we are not using that one. So wind load, so we can say basic wind spot 44 terrain category. You can go to this option. Yeah, now here you can see the terrain category 3 building class C, terrain category 3 building class C, automatic, the entire things are same, general building. Now for the wind load we can see X direction is 1, Y direction is 0. Another, we have this option additional wind load data. If you calculate your own values each and every floor, you can put it here, and the rest of the value you can put the 0, or else that particular existing load, means whatever the loads are coming according to the 44, but you wanted to put the additional wind load, then you can particularly level, you can put the additional load in the X, Y and the Z direction, that is the moment value, force Fxy and the moment value. If I go to the wind load profile, now you can see this is the profile of the story force, this is the story shear, and this is the overturning moment. One more thing is, this is the elevation, this is the pressure, this is the loaded height. Each and every floor you can see the values, how it is calculated. If you know the formula, just click on the make wind load calculation sheet. Now in this sheet you can see the wind load is equal to F equal to P into area into plus F dash. How the P is calculated, windward minus leeward into PZ. How the PZ is calculated, 0.6 into VZ square, and the VZ is calculated BB into K1, K2, K3 factors. So these are the some factors, and these values are mentioned here, and according to that in the below you can see the all the values. Okay, this all the values are same as what we did in the calculation of manual calculation. I just say apply. Now next is I will consider the wind Y. Rest of the things are same, only the my X values are 0 and Y will be the 1, and just say okay. Now my wind X and wind Y is generated. Close. Now I come to the next is seismic loading. I just say seismic load, just say add Now in the seismic load, I will just say earthquake X. Seismic code is IS 1893-2002. Seismic zone, say 3. Wait, I will check for this one. Yeah, it's a soil type is 2, seismic zone 3, and importance 1, and R is 3. Okay, so type is 2, 3, 1, damping factor 5. Now for the fundamental period, again according to the our IS 1893, we have the three formula. One is for the steel and the 2 is for the RCC. Again 2 is for with brick infill and without brick infill. So here based on that formula it will mention here. Right now I am using with brick infill panel. So the fourth option I will calculate based on the your geometry and the height. It will calculate the dimensions. I just say okay. Now it will take the value R value 3 factor 1. Here I will consider 0. Now here we have the accidental eccentricity, that is the positive earthquake X and the negative earthquake Y, positive earthquake Y and negative earthquake X. So these are the fourth options are available. Generally I'm using the normal earthquake X and Y, so no need to consider these two options. I just click on this. Say seismic load profile. You can see the story force, story shear, overturning moment. Each and every floor you can see the seismic weight, elevation, seismic force, and the story force, story shear. If I click here, from the here you can see in this diagram, uh, see, this is my total seismic weight, and this is my total AH value, that is the SA by G, Z by 2, I by R value. If I multiply these two value, I can get the my base shear. Even each and every floor you can see the values. So these options are available to cross check the your methods. I will just say apply. Now it will come here. Say earthquake Y, say 0. Here it will come 1 and say OK. Close. Now one more thing is, now one more question is come whether it is considered the additional torsional separately. Yes, you have to click on this option, inherent eccentricity. Okay, if you click on the inherent eccentricity, that is for the torsional amplification. So based on the eccentricity we are considering the 5% of the plant dimension. If it is coming more than that, then it will consider the additional moment to the members. So it develop the additional moments. Now one more thing is, now you can see here, once we generate the your these values, then come to the Windex, right click and just display. Now you can see all the forces are applied into the edge dimensions. I just off the nodes. Now you can see this is the X direction, FSI display. This is in the Y direction. Again earthquake X display in the X direction. So in this way you can identify whether in the which direction it will apply the forces. Okay, now both the earthquake X and Y is done. Now next is the dynamic loading. Come to the dynamic load, you have to click on the RS function. And in the RS function, no, you cannot see the additional moment and the shear separately. The total value you can see. You cannot see the additional how much the shear and the moment it will come. So it is coming only the total value. Now I come to the dynamic analysis. Just say dynamic load, say RS function, that is the response spectrum function. I just say add. Now in the add, I will just say design spectrum. Just select the code IS 1893-2002, soil type 3, sorry, seismic zone 3, soil type 2. It is rest of the things according to that. Just say okay. It will generate the period versus spectral data. And just say okay. Now my function is generated. Now next is cases. Just click on the RS load case. Give the name spec X, or else we can say RX. Direction XY. Excitation angle 0 means it is applied into the X direction. Excitation angle is 0. Then scale factor initially we consider 1. We are considering the 1893-2002 value. And accidental eccentricity, if you wanted to consider, you can consider. And I just say add. Similarly for RY, the same thing. And scale factor is 1. period modification factor, rest of the thing is 1, but angle is 90 degree you have to consider, and then I have to say add. Along that we have to model the eigenvalue, we have to analyze the eigenvalue analysis also. Means you have to just click here and you have to say eigenvector, eigenvalue, and the number of mode shape. I'm considering initially 12 number of mode shape, and just say okay. And if you wanted to know about the model combination control, just click on this dot dot option. You can see which are the methods are available. SRSS, that is the sum of root of sum of square, CQC, quadratic combine equations, ABS, absolute, and the linear. So these are the some options are available. And just say close. Now entire thing is done. Now one more question is come, how we can know that the additional shears and the moment. Actually after that you have to check the center of mass and the center of rigidity, how much the difference it will come. If it is the more than that, then you have to take that one. And the one more is the normal the moment, how much the normal moments are there and how much the my total moment is there, means design moment. See the difference. According to the difference you can see whether the additional moments will come or not. So it will see into the design part. So once you design the your structure, in the design you can see the detail calculation. In the detail calculation you can see how much the moments will come and what are the moments are there. Now when these things are done, now next is we have to run the program. I just run the program. In the table you can see the what is the my the moment, exact moment, means not the design moment, exact moment, means what is the my shear force and what is the my moment according to the element wise and according to the case wise and the combination wise. But in the designing, based on the additional moment it will come, that additional moment it you can see in the design part, not into the analysis part. Now next is once you done the run analysis, now you can see here we can see into the table only for the case wise and the combination wise what was the movements are coming. But what is the my design movement, in that design movement and what is my cases and the combination movement, it will might be a difference. So that difference make the additional movement. Now I will come to the make, you can see the 1.67 second is done for the analysis of the this whole structure. Now I wanted to check the results. Come to the results. I will say first combination. Just click on the combination and come to this option concrete design and just say auto generation. Now in the auto generation it is asking the 456 2000 and the scale of factor. So for scale of factor means you can unlock the model and change into the your load case, or else you can directly take into the combination, means here in the combinations also. So we can directly take into the combination. So first of all we have to check the load combinations values. Now one more question is come, that is the do you mean that additional torsional shear and the moment can appear in the design part output? Yes, in the design part output you can see, not in the result table type. In the design part you can see, but in the design part you cannot see the load cases, the actual movement. You can see only the design movement. So you have to compare with the both the values, and according to that you can finalize that how much the additional moment will come. Now come to the reaction. Say reaction force and moment. I just say self weight, say z values. If I wanted to know the value, just click apply. Now you can see the values. If you want into the tabular format, just click on this dot 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 option, this triple dot. I will just select the all the my combinations. Say none for the if you want the summation. If you want all the value, just click on the OK. Now I will come down. Now here you can see my sulfate is 54648. This is my SRDL. This is my lie load. My wind load is my earthquake load is, and this is my spectrum load is. Now we can see, I will just take the values. Now I will say, okay, my earthquake x value is 4711.299 divided by my Rx value is 181.93. So you can see the difference. So my factor is coming 2.22, okay, for the x direction, and for the y direction 2.42. So I will close this one and go to the load combination, and I will just say concrete design, say auto generation. My Rx is 2.22, add, and my Ry is 2.424, say add. Now this is the this one. Now even we have this 130 rule load combination also. Program will automatically take care of 130 role combination. You have to only define earthquake x versus Rx or earthquake y versus Ry. So according to that two cases you have to define. If I say okay, now here you can see program will take Rx into 2.22 into multiply with the factor, automatically take care into the combination. No need to go and change into the scale factor. Even program will calculate the serviceability load combination also based on the IS456. In the IS456 table, we have the serviceability load combination. According to that, it will calculate. So no need to go and manually define it the load combination. And this program will design the member for the worst condition. No need to go and manually define the anything. Now this is the one thing is done. Now load combination done, reaction is done. Go to the deformation, just say deform shape. I will just say select the wind X, say dx, animation, apply. I don't want to see the values, apply. Now in this way, if you just click on this record button, the program will show the displacement. Similarly, for the y direction also it will show, and according to that you can identify in the which direction your building is moving. If it is moving in the wrong direction, means you are applying the wrong forces. So this is the indication. Now next is the forces. If I come to the beam forces, and if I select any one combination, and if I say my for the beam, say value, if you want to see the values, otherwise I will just click here, apply. Sorry, beam force and beam diagram. Sorry, click on the beam diagram, my. If I say contours, apply. Now I just zoom it here. Now you can see this is the my movement. Okay, if I wanted to see the value, just click on the value, all, apply. Now you can see the values that is in the kilonewton meter. Okay, based on the unit. If you want into the detailed format, so just click on this option, quick view, click on this particular middle portion. Now you can see this is the combination sulfur 2. Here it is the value 4.5 meter level. What is the my value, minimum, maximum, all the value is mentioned, and you can click anywhere and you can get the value here. So this option is also available. You can see the total length is 9 meter and what are the my values are coming. So it is mentioned here. Otherwise, if you want into the detail format, just click on the beam detail, say beam detail analysis. Just come to the my, just click on the any one beam detail analysis. Just click on combination and just click on any one element. Now in the beam detail you can see this is my displacement, shear force diagram and bending moment diagram. If you want, you can in the red mark you can put any values and you can change the value, means you can check the value anywhere. Otherwise user defined also can click. Okay, similarly section stresses, you can see below, you have to click on the section depending upon the van missile maximum shear principal stress. In this part you can see the results. Now next is you can see the column diagram. Similarly, the wall diagram also you can see. See here below, you can see the values. Based on that, you can see the values. If you say value apply in the both direction, you can see plus minus both the values are there. So it is mentioned the diagram according to the USC. These three part we are giving the one wall ID, so it shows the one loading. Now next is about the mode shape. Come to the mode shape, I just say vibration mode shape, and I just click on this dot dot option. Now you can see this is the value, which is the period. You can see my first three mode shape, my period are coming 1.82, 1.74, 1.71. The summation, you can see here my summation in the x direction, it is coming here, it is in the 8 mode shape, and for y is also coming into the 8 mode shape. So according to that my design, so minimum number of mode shape I have to given is the 8 number of mode shape. If you wanted to see the variations of the mode shape, then click on the multi modes. I will just select any this one 4, 5, 6, 7, 8, 9 multi modes. I say vertically. Now in the one diagram you can see the various mode shapes. This is the mode shape 4, 5, 6, 7, 8, 9. This one is the fourth. So in this way you can check the mode shape and the values. So this thing is done. Now next is come to the result table. If you want into the result problem, just go to the story, and now here you can define the story. Say result table, story, and we have the story drift also. You can see story displacement, story shear force ratio, story mode shape, story eccentricity, story shear force ratio for what is how much for the beam and column for a frame, and how much for the wall, and the various checks are available: overturning moment, irregularity check, stiffness, soft story check, weak story check. So various checks are available. You just click on this option and you can see the various values. So these are the things are available in the MIDAS about the result table. So if you have any doubt regarding the modeling and the results, you can just ask me, or else you can mail us on techsupport@midasIT.com. This is our official technical support website, means a mail ID. If you face any problem, you can directly mail us on that mail ID. So now it's almost the 2 hour for the this particular session. Now we will take another 2 hours for the design as well as for the D-shop part also. Yeah, right. We are right now. I'm not explaining about the raft and these things, because it that concept of the designing the beam column and the raft is both are the different. So in the next part we are taking the raft designing. So we will intimate, or we will again send you the mail regarding the next webinar. In the next webinar we are saying the first design part about this same building, and the next we started for the raft model even with the design, and the similarly I will transfer it into the D shop also. So how we can take it into the D shop, I will say. So now it's almost the 1 o'clock is there. So the next session maybe the Mr. Prakash, he will send you the again second mail, and the similarly I will send you the same this recorded copy. Who all are present, who are not present, for all of them we send the recorded copy. It's up to you. You can again go through that your recorded copy. If you face any problem in the next session, we will discuss again. And if you have any problem, you can again mail us on the techsupport@midasIT.com. Yes, I will send you the recorded link also into the same your mail ID, your registered mail ID. And if you face any problem, you can mail us. Thank you for listening to me. And if you face any problem, you can mail us. And thank you for attending the webinar. Thank you, sir. Uh, still for the I'm hoping you all are again present for the next session also. In the next session I will again explain you about the design part of the same building and the raft modeling and the design part, and about the D shop also, a little bit about the D shop. Thank you, sir. Thank you, sir. Have a nice day, sir, and thank you for attending the webinar. We will see you in the next webinar. Yeah, thank you, sir.